And I think we're live. YouTube says we're live. Good evening, good afternoon, good morning, I guess, wherever you're coming from, if you're catching up live later. I'm Alex. Welcome to Norfolk Developers. This evening, we have another exceptionally well-named Alex to talk about serverless. I will leave him to give him his own introduction, and I will swiftly do an intro for Nordev and get out of your way for everyone is not here to hear me babble on. So serverless, what, why, and how? But before we get to that, a little shout out. So I will make a little caution for Alex did initially say that there will, he doesn't want to advertise too much Inawisdom. He was like, it's a talk. I'm just here to do the talk. I have taken it upon myself to advertise them for him. So join the team. Basically, there's a few people actually in our Discord, I think, from Inawisdom. So join them. They've got plenty of positions open. If you're looking for a new role, give them a shout. I'm sure either Alex or potentially Sam will field any questions you like. Quick shout out, if you would like to potentially come and speak this to us, give us a shout either on Discord or on the Twitters or wherever you can find us. Basically email. I think we've got a LinkedIn presence, but not too sure anyone's going to check it anytime soon, so not the best place. A quick shout out about the live stream that's, well, all this month. You've already missed two if you haven't caught up, but they will be on the YouTubes. You can catch next week's on Wednesday, 5:30. Tom will be showing us Unison, which is a really, well, if I'm honest, a pretty weird language that's based in a database. It's, yeah, it's going to take me a while to catch up with that, I think. But it's a Visual Studio extension, so a bit of TypeScript and, yeah, VS Code. So if you want to make your own extensions, there you go, basically. Virtual Social Club every Friday. Join us for games, a bit of chat. It's now on the Discord, although it might move back to Zoom, to be fair, because Discord's video calls aren't great. Quick shout out to the user story. Along with Discord, of course, we have a small challenge that goes on every 3 months. We pop a Pimmeroni voucher to basically the person that chats the most at the moment. But we are looking to rectify that, make it a bit more of a Stack Overflow thing, because a lot of questions are getting answered on there. So if you have a question, dev or otherwise, to be fair, come along and answer it. Ask it even, and someone will answer it, I'm sure. I'm going to skip past pet sponsors. If you'd like to sponsor us, give us a shout. Our patrons that I was then saying, kept the lights on. Without a NordevCon last year, we were sorely missing funds for, yeah, run-of-the-mill costs. Anyway, like I say, I'm going to get out of the way and pass swiftly on to Alex. Thank you very much.
He'll bore you within 30 seconds, I guarantee it.
I hear my old boss there.
It's a haunting voice for a moment.
You would be able to see my face, but my camera needs to be on.
There it is.
There we go.
There's a face.
Very, very bright for some reason. There we go. Right, screen share.
Paul literally looks like he's not there. It's like a red spot.
That's showing on the complete wrong screen, isn't it?
We get a sneak peek of your view.
I do like a good start. How is that?
Yep, perfect.
Is the Zoom thing in the way, or you're right?
No, perfect.
Cool.
No, it's just doing the presentation.
Brilliant. Yes, so thank you for coming to listen to me talk all about serverless this evening. Let's just talk a little about who I am. Yes, my name is Alex. I am a solution engineering consultant at Inawisdom. I have been with them for just over 3 months now. Inawisdom, for those of you who don't know, are based in Ipswich. So hopefully I'm not going to get any virtual tomatoes thrown at me. And are a AWS Premier Partner. We love everything cloud, and as Alex mentioned, are on a little bit of a hiring spree at the moment. So if you are like-minded, please do reach out. Previously, I was with BT, also down at Industrial Park in Ipswich, and a company who I'm sure many of you are familiar with up here in Norwich, ubisend. So I've got the shiny digital badges to say that I'm a certified AWS solution architect and developer. Anyone who is interested in cloud and is looking for a really good pathway to learn more about it, I would wholeheartedly recommend the certifications, and they really do help if you want to progress a career too. And by all means, reach out to me with any questions either at the end or afterwards on Twitter, or the website can be found as well there. So in terms of tonight, that's pretty much how I can sum up the talk. Want to kind of cover everything serverless, demystify all those questions that people often ask, cover a little bit about why you should use it, also why you shouldn't always use it, how you can get started with serverless on AWS in particular, and then finishing up with a live demo, which, all being well, will be good fun. So, serverless, what's it all about? Guess what? They're still there. The serverless is a little bit of a misnomer in that really it's the building and running of applications without thinking about the servers rather than without any actual servers. So hopefully no one was under the impression that it was too magical. The servers are still there somewhere, but the crucial thing is that as a developer or an operations person, you just haven't got to think about them. Serverless is probably most commonly known with functions as a service. So these are things like Lambda, Google Cloud Functions, and Azure Functions. So being able to run your really small units of code in a way where you just haven't got to worry about spinning up a virtual machine or provisioning a server, just being able to get your code out there. And a really common pattern for this is event-driven functions. So event-driven functions are, as they pretty much say on the tin, functions like a Lambda function that get invoked when something in particular happens. So it might be that you've uploaded a picture to Amazon S3, and then you have a function that automatically runs every time a picture gets uploaded to compress it and store it somewhere else. Or you might have a function which every time someone signs up to your newsletter, it gets an event to say, yeah, someone signed up, and your function goes off and sends them an email to say, please confirm that you want to hear from me. So this really kind of goes into the idea of one Lambda function having one responsibility. And this probably sounds familiar because essentially it's serverless and functions as a service in particular really do fit very well within the microservice architecture. And the reason for this is if we think about a use case the way you could have multiple serverless functions. So if we think about a normal kind of CRUD related application where we want to create a user, list users, and delete users. So these boxes on the right hand side represent the scale or the sort of horizontal scaling of our functions. So how many of them we've got running at a given time. And on the left, we're looking at the amount of requests coming into our application. So at the moment, we've got one person wanting to create a user, one request coming in to list users, and one coming in to delete users. Now, obviously, if we want to say, scale that up, then why would we want to bother scaling up listing and deleting users if the load is coming in to create users? There's no point slowing down traffic for everyone or spending the extra resource on doing that. But crucially, one place that serverless differs from more traditional architecture, because there's no reason why you couldn't theoretically put these different functions on different virtual machines. The crucial thing is with serverless, you can scale down to nothing. So if you have a particularly peaky workload for an application where, I don't know, it's say an e-commerce shop, and throughout the time of say 6 p.m. to 10 p.m. in the evening, you've got a really consistent number of requests coming into your application, but overnight, actually, the number of requests coming in are really few and far between, then obviously, why would you want to pay for resource if you're not using it? So the nice thing with serverless is it can scale right back down to absolutely nothing. And zero is zero functions, zero cost. So in terms of why serverless is a good idea, I've kind of got three quotes that I think sum it up really well. This first one from Cloudflare, who have now released their own variant of serverless functions, which is Cloudflare functions, which run on the edge of their network as a really, really fast way to get your functions on the absolute edge of the network and really close to your users. And what they say is that for many developers, serverless architectures offer greater scalability, more flexibility, and a quicker time to release, all at a reduced cost. The interesting bit about this that I want to pick out is this kind of idea about more flexibility and a quicker time to release. And I think this all plays into the real kind of uprising of DevOps as a principle at the moment, where more and more companies are going away from that model of here's our development team, here's our sort of pure operations team. That certainly from the sort of the companies that I've been in, even BT, where things are sort of as traditional as they're going to be, even their developers were empowered to deploy code into the cloud. And that's where I think serverless, taking away that responsibility and a need to understand how to set up and how to manage an operating system on a server and how to patch it and keep it up to date, taking away all of those responsibilities does give you more flexibility, because you're no longer reliant on that one person in the organization who knows how to write Bash. And the quicker time to release it is true, because it means that suddenly you've got a way for a developer to write some more code to define their infrastructure and just push it out into the cloud. And that's kind of it. Second quote is from Werner Vogels, who is the Amazon retail CTO. And his website is brilliant. Allthingsdistributed.com. It's absolutely fantastic if you want to get really deep into AWS. And he does a lot of stuff not just about AWS, even though that's his job. But that's really worth a read if you want to go a little bit deeper into this sort of stuff. He says that going serverless frees you to focus on activities that set your company apart, like product innovation. And again, that's all on that same theme of taking away the need and the want of understanding what's going on behind the scenes. Like if you don't need to know that your server is running this particular operating system and whatnot, then why would you want to know it? If I've got a Python script and I know it needs to run in Python 3.8 and it needs these dependencies, then that's all I want to be able to choose. I don't want to have to go in and select a particular version of Ubuntu, or dare I say it, Windows. But yeah. And then the final quote kind of pretty much sums me up. Serverless really does let me embrace my inner laziness, because it lets me get code out there without configuring a single server. And that, I think I put in the description of this talk, one of my real passions is trying to make development and getting code that people have written out there easier. And serverless is a huge help with that, because you pretty much half what you need to know. Certainly with some of the services that are coming out now. So in kind of summary of what serverless gives you and perhaps why you should use it, obviously it abstracts away the responsibility of provisioning, managing and scaling servers. Billing is one thing I haven't really touched on, but obviously with serverless, you really do pay for truly what you use. So it's very hard to be over provisioned with serverless. There are ways, but if you kind of go for the out of the box defaults, then you only pay for every invocation of your Lambda function. So if no one ever visits your website, then your website costs you nothing to host. So kind of everyone's a winner really. And that key one for me, which is delivering value to customers quicker, because at the end of the day, they're the ones that obviously pay our wages. And if we're able to get more out to them faster and better and more reliable, then that's only good. So I think one big kind of misconception about cloud is, well, AWS, I should perhaps say, is that it's a real kind of challenge to get into, and that it's this huge thing that is like a really big, deep pool that you can't sort of go in the shallow end. And what I want to do is try and break that myth, because by all means, AWS is a huge platform. And if you go in day one and try and do everything in the most complex way possible, then it probably will be overwhelming. But there are ways and means to go in a bit more gently. So I wanted to start by kind of looking at the landscape and where we are today. And I think that pretty much sums it up. It feels like at the moment, every new release that comes out of a cloud platform is serverless. It's like, you don't have to think about this, don't have to think about that, we'll manage it for you. And naturally you pay for it. But I wanted to obviously look at, how as a developer, you could go out tomorrow and get started with a serverless architecture. And this is probably the one biggest recommendation that I can make, and that's to use some form of infrastructure as code, whether it's CloudFormation on AWS or ARM templates on Azure, or Terraform if you want to go multi-cloud. Just something, because it makes life 10 times easier. There's a little bit of an upfront effort to learn how it's put together, but when something goes wrong and you have to deploy it into a new account or a different region or anything, it just makes life so much easier, because it almost becomes sort of self-documenting. So what I want to do today, I don't want to talk to you for 40 minutes without actually showing some code. As I want to look at 4 sort of serverless / fully managed services on AWS, which in combination with each other will allow you to put together, well, in this example, quite a simple application, but could very, very easily be expanded out to whatever you want it to be. So for those of you who don't know what these services do, I will go over them now. So API Gateway is essentially a very thin layer that can go on top of your lambdas. So you can define different paths. You can say, I want /users /list to go to this particular lambda, or I want post requests to /users to go to my create user lambda. You're able to do things like put authentication into it. There are some more complex features. You can do things like, you can do authentication in the sense of API keys. You can also go down the route of things like certificate authentication if you're doing machine-to-machine communication. Loads of things you can do with API Gateway. For tonight, it's going to be a really simple example of let's send to a hello world endpoint and do something with it. Lambda is the one I've been talking about so far. So it's AWS's flavor of functions as a service. The idea being that you upload your code, or more recently, you can also upload Docker images to Lambda and run them in there, which is a huge win because you can essentially now run anything in Lambda, really. If it completes within 15 minutes, then you can do it. DynamoDB is Amazon's NoSQL database, so it's brilliant. Amazon use it to power a lot of their retail website, and I think they've benchmarked it on days like kind of Black Friday and Prime Day at handling sort of millions of transactions per second. And the way I look at it is if it's scalable enough for Amazon on Prime Day, then I'm never going to hit the limit. So why worry? And then SQS is Simple Queue Service, which is Amazon's managed queue. And that comes in 2 flavors, one for normal queues and one for first in, first out queues. So what I want to do with these 4 services is put together this, essentially. So we'll have a API Gateway endpoint that we're going to send a request to. That will trigger a Lambda function, and that Lambda function is going to basically take our string and reverse it. That will then put it on a queue, and then the queue, a new message on the queue will trigger another Lambda function, which will then go on and store in DynamoDB. So without further ado, I'm going to dust off the keyboard and try and do some live coding. So I talked about infrastructure as code tools, and just before I get started, is the size of my terminal and editor all good? Yeah, good.
Terminal looks good. Yeah. Do you want to just bring up some text on VS Code? Yeah, looks good to me.
Brilliant. Cool. So in the AWS world, they have a really good way to get started with serverless, and it's called the Serverless Application Model, or SAM for short. So the SAM CLI gives you loads of different ways of getting started with a serverless application. And we use this really extensively in Inawisdom. Pretty much for every serverless workload gets started with SAM. So underneath, SAM is essentially a kind of transform on top of CloudFormation, which is Amazon's original infrastructure as code service. But that does mean that you can take a really simple SAM application, and as it gets more complex, you can add CloudFormation resources and grow it as the need comes. So to get started with a SAM application, all it is SAM init, and then they have quick start templates. So I mentioned earlier about how Lambda now accepts Docker-based containers as well, or Docker-based workloads as well as just regular code. For today, we're just going to go for the code option because it's all fairly straightforward. And I am going to write it in Python. And then let's give it a name. So what this will do is it obviously takes a template from Amazon's GitHub and creates that for us. And of course, at this moment, my internet decides to be incredibly slow. There we go. So what you get is you get a few different options. So you have things like the Hello World example, which is just a API and a function to return kind of Hello World. Then you have ones which are designed for being triggered on an event that comes from within AWS. So that might be, I don't know, if you're monitoring a sort of real server and the CPU goes above a certain level, you might want to trigger a Lambda function to terminate it and spin up a different one, as for an example. Step functions is a Amazon service for state machines, and then Elastic File System is it's a file system that you can connect up to Lambda to get persistent storage rather than the ephemeral storage that is more standard. So we're going to go for just the regular Hello World one, because that's going to give us what we want for now. So within this application, you get some sample events, which is what you would get from API Gateway after it's received a message or received a request. This you can use to test your Lambdas locally, which is a really nice thing to have. You've then got the application itself, which is just a requirements file to say what dependencies it has, and then the actual code itself. And then you have your template. And this template is, for anyone who's used CloudFormation before, it's CloudFormation with the exception of that line there. When you add this transform to this template, it allows you to do things like specify a serverless function rather than having to go in and specify a Lambda function. And the idea behind this is you have to specify an awful lot less at this level, rather than saying, I want a Lambda function and I want somewhere to put logs, and I want a role so it can access the logs, and I want the event mapping so that it can get triggered by the API. Rather than having all of that, you can do it all within this one kind of block and say, yeah, it's an API, this path, this type of request should trigger this function. So what we are going to do first is just to show you that it is real and that it isn't all smoke and mirrors. We are going to change this here to return our body that we send in the request. So we will have this here. And then let's tidy up all of this so we're not confusing matters. And then we will just return our body. So what this will do is, it's just going to take whatever we send to the API and spit it out right back to us. So what I'm going to do is I am going to get some credentials so I can deploy into my account and not show the world that. So now I've got my AWS credentials set up, so I can see that I've got my role in my account and everything like that. And then all I have to do is do sam deploy. And if I was in the right folder, it'd be a really good start. And it will guide me through what I need to fill in. So the stack name identifies this particular application in CloudFormation. So we can call it this, for example. We'll deploy it into Ireland, and we want to confirm our changes before we deploy things. We want to let Sam create roles for us. And for now, we're happy that our API hasn't got any authentication, and that did not happen when I practiced. Talked that one up, didn't I? Security constraints not satisfied.
Live demos never go, they always go really well. There's, no problems.
Well, this is very strange. I will try one more. There will be a brief interlude whilst I sort this out.
Need to get Sean to get the guitar out. Need some elevator music. Da, 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 da. Yeah, I'm not going to carry on. Nobody wants to hear me sing.
I feel like I might have given the wrong answer again.
Get the tiny guitar out. It's more entertaining from a visual perspective. I won't actually play it because that would be embarrassing.
I should have read what was on the screen, shouldn't I? If I'd said yes to that question, it would have worked.
The default answers are a bit weird, different.
Cool. So what this will do for us is it'll save all of these values to this file here. So next time we deploy it, we haven't got to do the deploy -- guided, because we can just do sam deploy and it will pick up our things from here. So because I answered yes to the confirm question, it tells me what it's creating. So from this one block in our template here, to say I've got code here, it's in Python, it's an API, and I want this path, it's going to create our 3 API gateway resources for us. It's going to create our Lambda function, our role, and our permission to say that the API can invoke our Lambda function. So we can now deploy that. And whilst this is deploying, how are we doing for time, Alex? Are we all right?
Very good question.
I can't remember what you said as the end.
I think you've got another 10 minutes, to be honest.
Another 10 minutes. Cool. I will go as far as I can go. I can skip a few steps, it's all right.
It's all good. We push beyond it quite regularly, to be fair. It's like 45 minutes to an hour.
Okay. If I read the screen, I would have saved 5 minutes.
That's part of the fun of watching somebody do live code, though. That frustration is the same frustration everybody gets daily, but to see somebody else do it is, anyway.
Almost entertainment, isn't it?
It's not entertainment, it's affirmative. It's reassuring, right? It helps with that imposter syndrome. Anyway, I'll let you go on.
You're right.
Big things.
Yeah, so once we've got our application deployed, we can then see our stack name we chose of nordev demo. And we can see all those resources in here that we saw on our terminal. And what we can see is if we go into Lambda, we will see our hello world function. And crucially, the most fun part is we can now see here our API endpoint. So what we can do is we can send a request to our API, and we will get back nothing because it needs to be a post request, doesn't it, to have a body? At least I can show how we how quickly changes can be made to your live application. So what you get is when you do make a change, it creates a change set for you, and it shows you exactly what's going to happen. So it'll say, actually, we're deleting this deployment of our API because I've changed a method from get to post. So it's going to delete that one and create a new version of our API for us. And because it's changed the version of the API, it then needs to change the permission to say that this version can now, this version can now call our Lambda function. So if we go back here and try again and send it some text. We get back our message that we sent. So at this moment, it's purely just an echo function, essentially, just showing that we're sending something to it and we're getting something back. So what we can do next is we can look at our next step of the process, which is reversing the text and putting it on the queue. So let's update the code in here first, so that we, actually no, let's do this one first because that'll make more sense. So what we can do is we can define our queue. So a queue is of type AWS SQS queue, and that queue has properties to say our queue name is just going to be, let's call it nordev processing queue. And just like that, I've now defined a queue that we can use. Unfortunately, it's not quite as simple as that, because we need to do things like pass into our Lambda function where to access this queue. So we can do that using environment variables, as you would use in any other application. So we can set up here environment variables, and we can pass in our queue called processing queue. So different resource types have different returns. So it just happens that the queue resource, when you reference it in a template, it returns the URL of the queue that we then use in the AWS SDK to send some messages. Alongside this, because AWS works on a sort of least privilege approach in terms of identity and access management, we need to add a policy in there to say that we're allowed to access this queue and we're allowed to send messages to it. So we can add a policy here to say grant sending message to queue, and we're going to allow that, and the action we're going to allow is SQS send message, and the resource that we're going to target with that is again going to be our queue. So this is something else you can do, is the resource in CloudFormation will return something by default, which in our case is the URL here, but they'll also return attributes that we can reference. So in this case, we're getting the ARN, which is the Amazon resource name, which will give us the format we need for this policy statement here. So now that we've got that in here, we know we're going to be able to access the URL for the queue. We know we've got permission to do something with that queue. We can update our code, and we can actually put the message on the queue when we send it. So we're going to import the AWS SDK for Python. We're going to get this started with a client for our SQS service. And what we are going to do is, we know that our message is going to be in the message key, because that is where we're sending it. So what we want to do is, we then want to reverse our message, which is just going to be like that. Python has a strange but sort of satisfying way of doing it. And then what we can do is we can build up the message we're going to send to the queue. So let's build that up now. So we will have the original one, which is message, and the reversed one, which is going to be reverse message. Then we can use our client we built already, and we can say send message. We can specify the URL to the queue, which we passed in with environment variables. So we can say, let's get that queue URL from there. And then the body for our key message is going to be the JSON stringified version of our dictionary here that we've built up. So what we're then going to do is, rather than returning our original body this time, I'm going to return the response from the request to our queue, because that is going to give us some feedback and show us that actually we're doing something. So let's just get that deployed. So we can see it's creating our queue for us. It's changing the role because we've given it more permissions. It's modifying our Lambda function because we're deploying a new version of the code. And then it's modifying our API because the API is now going to be pointing to a different version of that Lambda. So all being well, what we can now do is send this hello message to our Lambda, and back we will get the response from SQS. If someone wants to try and dehash that, they are more than welcome to verify that it is what it says it is. Probably haven't got time to do it live. Essentially, if we now look at our queue in SQS, we can have a look at it live. And we've got a message on there. This ID will match up with our ID here. And if we look at the message, we can see what we've put on there. So we've now got a Lambda that's being triggered by an API endpoint, and that is then going to put something on the queue. So if we're still all right for time, yeah, cool. I will keep on. So now we've got this. We've got our Lambda, we've got our queue. Next step in our diagram was a Lambda to act as a consumer of this queue. So it's this next Lambda will be triggered every time a message goes onto that queue. So let's build up a another Lambda that I am going to just save some time. And we'll call this one, say, storer function. And we're going to store it in the, we're going to put the code in the storer directory. We don't need that anymore. We are going to need something else. And we don't need this anymore. Again, we are going to need something else. So what we'll have is we'll have this time, rather than being triggered by the API, because we don't want two Lambdas to be triggered at the same time by the same endpoint, because there's not really a lot of point. We will have it be triggered by the queue instead. So let's get it to be triggered by SQS. We can then pass in here. All you pass in is queue, and then you give it the ARN like we used in the policy before, like that. And that will then allow us to trigger this Lambda whenever we get something on the queue. So let's just copy and paste this so we can get another Lambda in here. And we'll call this one storer. And we don't want that anymore. And we don't want any of this anymore. So the last step of our process was to store this on a DynamoDB table. So what we're going to do next is the SAM framework also allows you to build up really simple DynamoDB tables in these templates. So we can build a table up here. We can say it's going to be of type serverless simple table. Our properties are going to be, all I want to do is just tell it what the key is going to be. That's going to be a string, and our name is going to be, we'll use the message of the key, shall we? That makes sense. So what we're going to want is we're going to want to pass in the name of this table, because I haven't given it a name for no particular reason. CloudFormation will generate a name for you, but because you can reference it, there isn't really much need in giving it a name. So I'm going to reference it here and say I want to pass that in there. And then again, we'll put another policy into this Lambda that allows us to put a item on that table. So it's going to be DynamoDB put item, and then the resource is going to be using our get attribute again, storage table dot arn. In fact, I can't do that because that doesn't exist. So I'm going to copy and paste from my notes here that I made earlier. What you can do as well is you can use this substitute command and you can pass in kind of dynamic parameters. So I'm going to pass in the name of the table here. I'm also going to pass in my AWS account ID and the region this is deployed in to build up the ARN for us manually rather than using the get attribute, because from memory it doesn't exist on that. Queue we've set up already, so that's going to trigger it from there. And I think all there is now is to write the code to store it in DynamoDB. So we're going to want another client up here like we had for SQS, but for DynamoDB. So we can do that. Then when you receive messages from SQS, Lambdas can receive by default up to 10 records at a time. You can specify more, you can specify sort of one-to-one mapping. But in terms of saving some resource and making it a bit more efficient, you can get a Lambda to process multiple records. So what we can do is we always code to assume that multiple records are coming through, because then you haven't got to change your code if in the future you decide to just start sending more through. So all we're going to do is get that and then loop over our records that we receive. Then we're going to have our body, which will be in here, and this will give us the contents of that given message on the queue. And then we're going to build up the item we're going to put on DynamoDB table. So we know our key that we have to have populated is message. When you build up an item for Dynamo, you also have to specify the type. So S for string, and then we're going to say body, and it was original, wasn't it? I think we called it. And then we're going to put another attribute on that particular item, and we're going to call it reversed. And again, it's going to be a string, and this time it will be reversed. So then all we have left to do is put the item on the DynamoDB table. Obviously, it needs to know where to put it, and that's going to be stored in our table name, if I recall correctly. Yep, table name environment variable, and then our item is going to be our item there. So, and let's, for fun, do this as well. So what you can also do is you can, as well as receiving the event into the Lambda, you get access to this context. And this context is things like the ID of the request that has invoked that Lambda. So when you look at the logs, you'll be able to trace which Lambda in particular put this item on the DynamoDB table, because we can trace that request back. And there's loads of things in that context there that we can get access to. That's just one. So we can see here, we're deploying again. we are creating a table. We are creating a mapping to say, I want my Lambda function to be triggered on that queue. Then we've got a role for that Lambda and then the Lambda itself. So this is almost there. And then, all being well, what will probably happen is as soon as this Lambda comes online, it's going to take our message from our queue here and stick it on Dynamo table for us. And this is the last step.
I feel like we need that drum roll now. For sure.
Please don't. You can see we've gone from one message being available to one message in flight. So when a message is in flight, it means it's being picked up by a consumer of that queue, in which case, in our case, is Lambda. And we should hopefully not see that because it means that the function has not succeeded. So we can just quickly have a look at the log and see why it has not succeeded. And it will inevitably be something silly. So we have got the nordev storer function. We can look at the log here. And unknown parameter in input. Have I? That should have gone in there instead. And when all you're doing is just deploying code, it is really quick. If you are, however, doing containers, then it will take a little bit longer because it does build your image locally, pushes it up to Amazon's container registry, which is ECR, which is also worth a look if you are stuck in using Docker Hub, which I think I've lost track if it's supported or not anymore. So now we will hopefully see, if we look in our log here again, did I actually save it? Yeah. Gone, lovely. So if we look in Dynamo, what we will now see is, if we look at our items, this is the table name that it generated for us. We've got our message, we've got our AWS request ID, which we can trace back to our request ID here. And we've got our reversed one. So what we should now find is if we send another request like that, it hits our first Lambda, sends us a response back from the queue, goes onto the queue, second Lambda picks it up, and the second Lambda will then put it into here, like so. And that's what I expected to happen. So we got there in the end. That's everything I had planned for today. The great thing with serverless is that you can start like this and have a solution put together for something really, really quickly. And then the more complex your requirements become, the opportunities are really limitless because you have the full power of AWS at your fingertips. But the most important thing is you haven't got to go there straight away. You can start small and work your way up to the bigger services if you need them. Lambda, DynamoDB, and SQS kind of underpin so many kind of big name websites, applications, that really you learn the skills once, and they are transferable across lots of different projects. So I really hope this has been helpful, and that you've enjoyed watching me make typos and eventually get there. But yeah, any questions that anybody has, please feel free to shout either now or afterwards, or I don't know if Alex has got any queued up from YouTube or Zoom.
I have put a shout out on YouTube, but it seems we've had quite a few people slip behind. So there's currently 45 people behind. So I guess they will catch up in a moment. And I've put a shout out to say, put your messages in or your questions in Discord. Are you on Discord, Alex?
Yes, I think so.
He's getting called out now. Message from Joe. Talking of Joe, do you have any tips for managing permissions?
For managing permissions, it's quite a wide area to give one tip for. I think if it's in the sense of managing permissions from a development practice point of view, so someone setting up permissions on AWS for developers to then use to develop on AWS in a way that suits their access requirements, then permissions boundaries are a really good thing to look into. So essentially what you can do is you can specify the outer limits of what permissions somebody is able to have. And what that means is you can then say, X developer is able to create a role, but they can only create this role if it has this permissions boundary attached to it. So if you say, my permissions boundary is I'm going to deny access to any S3 bucket that has personal information in, because I know that I don't want my developers seeing that, but I want them to be able to use Lambda and Dynamo and whatnot. So you could put a permissions boundary in to say, allow everything except for accessing these buckets. And then a condition on that particular developer's role to say, yeah, they can create roles, they can create policies, anything like that, but only if that permissions boundary is attached. And that then means that they're free to go and create lambdas and create the roles for those lambdas. Even inside SAM, there's a really easy way to attach permissions boundaries. You literally just have to add them there. You haven't got to go and create the role separately. You can just add the permissions boundary that's been created on your behalf. That's a really good way to limit what developers can look at. If it's on the thread of managing permissions for services, so say looking at Lambda and trying to figure out what it needs. So rather than giving it a wildcard for the service and a wildcard for the resources, what you have now got is a pattern that I've used in the past is to start with to give it access to everything in a development account, because then you know that it's going to work essentially. But then what you've got is there's this new service in IAM called Access Analyzer. So what you're able to do is you can create your analyzer here, and you are able to look at what access resources really need. So essentially you can then scope your policy for that particular service or resource down to what it's actually been calling. So that's a really easy way to identify where your policies might be over permissive.
That's pretty cool. So that's effectively kind of analyzing logs to say that this resource actually read from this particular resource. So that's probably a permission you need in the set. Oh, that's fantastic. Nice. Joe says, thanks. How about the lambdas themselves? Do you create policies for each function or go broader than that?
So I would say it depends what you're doing. So if you are doing something like the example I gave earlier, which was the create list and read users, then the chances are that they're all going to be reading from the same place, they're all going to be writing to the same place, they're all going to have access to the same thing. So you could give them all the same role. However, probably if you go by best practice, what would be the better way of doing it would be to build a policy that gives access to all the required resources and call it Lambda user access policy or something, and then have a separate role for each of the Lambdas that has that policy attached to it. Because then what you'll often find is that you'll get 12 months down the line, you'll forget that all three Lambdas have got the same role attached to them. One of them will then have a requirement to look at something really sensitive. You'll give one Lambda because that's the role that you see on that Lambda access to it. But inadvertently, you've then given three Lambdas access to it because you started off by sharing roles. Generally, roles are the way to go on services. And the same for individuals as well, actually. A really good pattern that should be used for individual access to AWS is either something like SSO, like I use here. So I have one username and password I log into and can then get into each of the three accounts in the organization. I have admin to all of them because they're mine, but you could set up a developer role, for example, that all of your developers use. And then if there's one particular person that needs to have a bit more access, then best practice is to, rather than calling the role Alex, you'd use it to describe the elevator permissions. So it might be power user, or it might be database administrator, and then you keep those roles as closely scoped down as possible, so that if you have to switch between two different roles to do two different things, it's not necessarily a bad thing from an individual perspective, because it means that if one set of credentials gets leaked, you haven't given the attacker the keys to the whole kingdom, you've just given them a small corner of it.
Good answers, and same as Joe's concluded as well. It actually ties a little into my question, but I'll ask that in a minute. We've had a question in from Jake, who's on a train at the moment with some dodgy Wi-Fi. So we'll see how long that holds out. Go. Fire away.
I'll try and be quick while I'm somewhere not in the sticks. Hey Alex, thanks for that. A couple of questions, but maybe just answer one of them, because otherwise we'll be here all night. Just getting started with serverless. Obviously, you've got loads of projects on the go using Node Express and so on. Is there any reasonable means of kind of converting functions to be serverless rather than having to write the entire code base again from scratch? And then the other one was more to do with kind of live updates, sockets, that kind of thing, and how, given that these functions are obviously designed to be fast turnaround requests, how you would handle continuous connections for ongoing communication between client server.
Yeah, sure. So on the first point, although Lambda fits really well with microservice architecture, there's no technical reason why you couldn't run a monolithic application in it. So there's nothing to stop you from taking your Express app dropping it into the Lambda. And what you can do is you can, if you have your API gateway route set up as a wildcard, so you can do something where I've put /hello world, wherever it is, or /hello. What you can do is, I think the syntax is something regex like. I can't remember off the top of my head, but you can essentially wildcard it and say, send every request into this Lambda, and then you'd use Express to handle the routing. And essentially it becomes a monolith inside your Lambda. So no, that's how things like Laravel Vapor, for those of you in the
I was about to
work,
literally, I was going to say,
works.
before people start throwing digital tomatoes at me, in the PHP world, I use Lambdas for Vapor, which is a giant monolithic PHP app. So yeah, and that's how it works with the wildcard pathing.
And your second point, WebSockets, I think off the top of my head, API Gateway supports WebSockets. So you can do WebSocket APIs, but then go into Lambda functions.
Do you know they time out? Because we quite often have shows and so on that are kind of 4 hours, 5 hours long, or whatever.
So Lambda functions have a 15-minute timeout on them, but you could, you could point an API gateway to anything really inside AWS. You've got things like essentially acts as a proxy in front of something else. So
Right, understood.
yeah, whilst Lambda times out, other things wouldn't.
Got it. Thank you.
We've had some good success with using a third-party pusher for WebSockets. So they handle the WebSocket gateways and stuff and then pass it on to you however you like.
Yeah, and similarly, you pay for each message that's sent over it or whatever.
Yeah, it's quite expensive.
Yeah, I think that's why I dropped that idea.
There is one other one. There's pusher, and then there's what's it called?
The more expensive one.
No, it's an open source one.
Is it?
Yeah, it's going to
like the sound of that. What's that one?
Joe says API, Joe on YouTube, thanks. An API gateway handles that timeout with Lambda, as far as he knows. So
learn something new every day.
Indeed.
Socket.io, that's the one.
And just as you said that, Joe's also put that in chat.
Yeah.
Interesting. Okay, cool. Well, if there are no more questions from the YouTube lot, I'm going to drop the stream and spend the rest of the evening that sounds weird a bit now. I'm hesitating to say it, but in a private Zoom. Thanks for your questions, Joe. And if anyone else, again, has any further questions, drop them in Discord. I'll get them over to Alex and we'll get you answered. But yeah, thanks for joining us. I think we're meant to, at this point, say subscribe and like the channel. Anyway, see you later.
Thank you all.